This is Clarence. He had a terrible accident where he fell out of a helicopter and got hit by a car. Because of his terrible injuries, his doctor prescribed him antibiotics so that he could prevent infection. These antibiotics work by binding to small subunits of a ribosome. Ribosomes build new proteins through translation of mRNA that hold genetic coding. This process is explained through the central dogma. Essentially, DNA is transcripted into mRNA, which holds the information to make a protein. This mRNA is translated into a protein by binding to a ribosome's acceptor site.
The antibiotics bind at a ribosome's receptor site, interfering with the recognition of mRNA, creating mistakes in protein building. However, Clarence begins to feel sick and feels like the antibiotics aren't working. After talking to his doctor, he finds out that it's because he developed antibiotic resistance, since he hasn't stopped using his antibiotics from his last injury. One way this happens is through aminoglycoside modifying enzymes. These enzymes attack antibiotics directly so they can't attach to their targets. There are 3 types of modifying enzymes. O-nucleotidyltransferase. Add a nucleotide to the antibiotic. An example looks like
N-acetyltransferase adds an acetyl group to the antibiotic. An example looks like O-phosphotransferase connects a phosphate to the antibiotic. An example looks like this. These modifications stop the antibiotics from working properly and producing proteins that can stop the spread of disease and infection. If Clarence was not taking antibiotics before his injury, his body would not have developed antibiotic resistance. Resistance like this can be prevented by only taking antibiotics when you absolutely need them. Don't end up like Clarence, and don't rely on antibiotics for daily use.